let's get started. We are going to go over collections today and stacks and queues, and I'm going to probably get through about, I don't know, maybe 2 or 3 slides. Give you some basic concepts so I can give you the big picture. Then I'm going to go out to Eclipse and start writing assignment number 3 for you so we can get that over with. So I don't know how many assignments there are. 4 or 5 of them or so. I think maybe 5. So we're at the halfway point, so we should be almost done with assignment number 3 today. So I'm going to show you abstract classes, I'm going to show you interfaces, I'm going to show you inheritance, stacks and queues, and collections, and the concept of data structures. Did you have a question, or are you just stretching? He was just stretching, I guess. Alright, so this is lecture number 6, for those of you who are following along. And what I want to do is kind of give you the concept, show you the package, and then I'll stop the lecture, and then we'll finish it up on Monday, and we'll finish the rest of this lecture up. But here's the concept. We're talking about data structures, but the reason why we're talking about it, if you're computer science people, you shouldn't be familiar with data structures at a minimum, because data structures are used in everything. Even in the Android operating system environment, in application development, there's the use of data structures. So the concept being that we have a collection, and it's a collection framework is what they call it in Java. It's a collection of data structures. And what is that? It's actually an object to hold other objects. So we have different types that fall into this category. So these are objects which let you store and organize objects in useful ways for efficient access. So you don't actually have to reinvent the wheel when you want to create a stack or a queue, and I'll be talking about those. I mentioned the concepts last Monday, so we're continuing with that. And so we're looking at today the java.util package, and we'll be importing that and using that for ArrayLists, for stacks, for queues, for all sorts of different goodies that are inside of that. Lots of interfaces. We know what interfaces are because we saw that last time, and I'll remind you of that as soon as we start looking at the source. Interfaces and classes, a general collection framework, so programmers may also provide implementations specific to their own requirements. And you don't have to use this at all. Actually, you can create your own stack or your own queue. In the old days, if you were a C++ programmer and you or a C programmer, you used pointers to create linked lists for lists, or you created old-fashioned array lists by using an array structure. And I'll show you a simple array structure today as well. And you did things kind of the manual way. And then, actually, even in C++, now we have libraries that you can import in, or include, I should say. And those included in those libraries, you get a bunch of things in the collection category. And the collection categories are all of the objects that hold objects, essentially. But a collection is a more generic way of saying a list, or a set, or something that would be associated with it. So if you think higher up a hierarchy, a collection has everything in it. A list is usually an ordered collection because we have a list, we have 1, 2, 3, there's some sort of order in it. A stack, as we've seen, is usually in some sort of last in, first out order. A queue is a first in, first out order. We have like maps, and we have trees, and we have hashes, and all sorts of other things that also belong in the collections category. So here's the bottom of the slide is probably the most important thing to kind of focus on. Let me see if I can make it a little bit bigger so we can kind of see it. In the framework, we have the blanket object called the collection. When we include java.util, we get that. So we get it with Java. And, why do they call it collections? Well, there is, and I'll show you. There's a subclass. There's a subcategory in there in that package called collection. Inside the collection, we have sets and lists. Sets usually are in hash values of either hash sets, and the hash set is basically 2 values, a value and a key. So we have a key, and then the key, each one of the keys has a value associated with it. Sort of like a dictionary. So if you don't like the word hash, you say the word dictionary. That's pretty much the same thing. A list is single items, and we have 2 types of lists. We have array lists and linked lists. If you're not a C++ programmer, you probably have never heard of linked. Maybe you have, maybe you're not, because Java doesn't have pointers, but C++ does and C does. So the way we created a list in C or C++ is we created pointers, and we had pointers pointing to other pointers to other pointers to other pointers, and kind of a mess, actually. Not really a mess, but it was kind of difficult for some people to do, and it was called a linked list. And I'm sure everybody kind of remember we had the concept of a node in there, and the node was inside of a list. And well, we're needed to create those because an array list used to be in most languages. Not even say array list, just say array. Array is usually static in nature, which means you declare the size of the array at the beginning of the program. You say you want 5 items in there, and then later on in the program you have 6 items. What do? You can't expand the array. The array is kind of stuck. Same problem in C++, same problem in Java actually if you create an array. If you use an array list, you're using an abstract data type from the collections package that is in the list category. That's called an array list, and the array list is allowing you to do things dynamically because it's an object, not a primitive data type, and the object has methods that allow it to grow, shrink, allow it to do whatever you want it to do, essentially. And we'll see that today in the source code. On the other side of the fence, we have the sets. The sets I mentioned before. We have the hash set. We also have the sorted set. What's a sorted set? It's like a tree, you know, binary search trees. They don't have to be binary search trees. There's all sorts of different tree type structures that we can work with. The tree is essentially an order, but it's not a list, and it's not a set. You know, there's a relationship between all the different items. One comes before the other. So we'll see examples of hash sets, trees, arrays, and linked lists in terms of how we program with that. One of the other items that comes along with the util package that's not part of the collection, see, these are in the collection category because they're all objects that hold other objects. And objects can be anything. Outside of the collection, we have the map. The map comes in a couple of different forms. We have the hash map, and then we have the weak hash map, depending upon the type of map we're creating. And for the purposes of this lecture, and for understanding the basic concept, think of a map as a regular map, you know, like a city map, where we have connections between, sort of like an elaborated tree, but it's traversed differently. So we know we can have a map that shows geographic, say for example, a geographic map. Very similar in concept, actually, but programmatically we have connections between different areas. I'm not going to really work with maps. I believe I have one example that uses a map, but it's not, you know, not really that big of a deal. The sorted map turns into the tree map, actually, and the tree map is kind of a tree with more structure to it, with more location-oriented, section-level orientation to it. So if you're not familiar with data structures, you're probably not going to get this part of it, but don't worry about it. You don't have to program in it for this particular class, and you can still understand Java and how to program in object orientation without ever understanding what a map is. But in concept, it's very similar to what you already know. And then we have this thing called the iterator. The iterator is a separate object. So most people, when they have learned non-object oriented programming techniques for creating and using data structures, they built their own iterator inside of the structure. So an iterator, sort of like a loop, sort of like a process, sort of like a flow, control of the flow. Iterator goes through like one item, one at a time, or it could go through a whole list. You can read it forward or read it backwards. So the iterator, list iterator, is used for list to traverse the list. We can also put an iterator on a map or a tree, actually. And on the tree, we're going to traverse the tree, read the tree from node to node. The iterator is a separate object, however, and so you have to think sort of out of the box on this. It's not something that you probably have worked with before in terms of concept, unless you've seen this, worked with this. It's very different than C or C++, although the current APIs now have libraries for iterators, libraries for maps, and all sorts of different things as well. So it's pretty equivalent, but originally it never was. So it depends on how many years ago you've been doing your C++ programming. But the iterator will make an object. I'll have an example that makes an object of the iterator. So we have the list object, we have an iterator object, we apply the iterator to the list, and we have it do stuff to the list, essentially. Or we feed one to the other, and we have them work together. Not really part of the same structure, which is interesting. So here's our root interface. Remember the word interface that we saw before? Interfaces have the ability for you to implement functionality associated with the object and the object's behavior. Methods that work with an individual collection, as an example, and the root interface would say that Size is probably an important one. Is empty is probably important. You know, have to check to see if there's anything in the list, not in the list. How big is the list? Does it contain this object? You know, giving it an object element. We want to add an object, remove an object. Is it equal? Is it not equal? Hash code of the object, perhaps, to see what object it is, maybe for a comparison. An iterator. Maybe to array or to a string, actually not on the list here, probably an optional thing you can put in there. But if you remember, the interface is sort of the template for the implementation, and the interface tells us what methods are going to exist. And the same interface, root interface, works for all of the different items in the collection. So you know you can run .add and add an element to anything, or you can run size or is empty and have it return true or false to tell you whether something is empty or not. Which is one of the reasons why interfaces, going back to that concept from Monday, is kind of an important concept, because the interface gives us the contract, gives us the information that we're going to expect each one of these classes to have. In a continuation of this list, we have a lot of them actually. It's just a small portion. Not all of them are listed here. There's other methods that you can run on root interfaces, other methods that you can run on instances of objects that come from this hierarchy. Primary method linking or bulking, operating in bulk on another collection might be to test one collection with another and say, are all the items in this collection also in this one? You know, are the lists the same, or there are crosses between the lists? And think of this more like SQL actually on tables, if you think of it that way. You know, when you have the Boolean contains all, so we could say, does one connection contain all the elements of the other connection? And we know it's the same group. Add all of them from one to the other, remove all, retain all, clear. You know, these are just basic methods. The SDK does not provide any direct implementations of the collection interface. You have to provide your own direct implementation, and basic ones, actually, this is kind of deceiving. You do have some basic implementation, and we'll see that in a few minutes, but for the most part, you're implementing what it means to remove all or to retain all. Most of the actual collection types implement the interface, usually implementing an extending class called a setter list. So if you want, you can go back up the hierarchy and use the collection. Or you can go further down the hierarchy, make an instance of an object called set or list, and we'll see that in a few minutes, and then run the implementation for a list. And then we can actually run queue or stack, which is from list. And then we can see, well, you know, for the implementation for an add is different for the queue as it is for the stack. One adds it to one end, the other one adds it to the other end of the list. And we can kind of see what the differences are in terms of the implementation. For the purposes of your third assignment, you can use anything you want, actually. You can implement it yourself, or you can take the easy way out, and I'll show you the easy way out, actually. I've got a stack and a queue that's actually created for you already. So you pretty much just need to apply it towards the concept. So the interface is typically used to pass collections around, manipulate them, where maximum generality is desired. And it is pretty general as a data structure if you think about the concept. The iterator, as I mentioned before, is used to traverse through the items of the list or the collection. The collection interface defines an iterator method to return an object implementing the iterator interface. So each one of the collection items in the interface actually has an iterator. You can create a separate iterator item, or you can use the iterator method. You can implement it, you can override it if you want to. So it can access the elements in a collection without exposing its internal structure. There are no guarantees concerning the order in which the elements are returned in a collection, unless you're looking at an ordered list of some sort that you've created. So then we have 3 defined methods for the iterator interface. And these are the methods that you'll be using if you create an iterator object, or if you use the iterator method off of one of the lists or queues or stacks or something. We can run a hasNext, a next, a remove, basically going from next item, next item, next item in some sort of an order. Or maybe it's not even in an order. We just take one item out, take another item out, whichever one happens to be there. Next item out, next item out. So returns true if the iterator has more elements. The hasNext says, yeah, there's more stuff in there you haven't looked at yet. Next returns the next element in the iteration. So an exception will be thrown if there's no next element. So usually you use these in combination. You say, has next? Oh, yes. Okay, return it. It doesn't? Okay, don't return anything. Otherwise you have to go through exception handling. And so it's one way or the other. Either that or throw an exception. I'm going to show you an example of exception handling today, but we have an entire lecture on that as well. Removes an element from the last returned element, and if by the iterator, can be called only once per call of next. Otherwise, the exception is thrown because there's nothing to remove. Next element is gone. So until you say next, and it doesn't get the next one. So it only works with the current one. And so here's an example of classical routines using an iterator. So it's a method called remove long strings, and we send the method a collection, and we're sending it an integer value for the maximum length. And then we're saying iterator IT, so we're making an instance of this iterator. The instance of this object is called IT. We're going to call on the collection here that we're sending it to. We're saying it's equal to this collection.iterator method. So we're running the iterator method on the collection to say, give me your iterator. And then while IT has next, which means while there's items in there, this is always going to be true if there's an item in the list, or in the collection, I should say. Quit calling it list. Then I can say, well, string, and then take this guy here, and now we're typecasting it to string. We're taking it.next, which is the next element, which hopefully is carrying something that can be converted to a string. Well, if it's an integer, if it's a number of some sort, it can be converted to a string, no problem, or if it's already a string. And then look at the length. So on the string, we can run .length, which is a method that's available from the string object, and say, well, if it's larger than this maximum length, and this maximum length we sent to the method, so we know what that is, then remove it. So we're going to basically take a collection and shorten it to this maximum length by running this method, essentially, on the collection. And we have the list iterator that we can create as a separate object. The list iterator is the lister iterator interface, extends iterator interface. There's a tongue twisters for you. Adds methods to manipulate the ordered list object during iteration. So this is essentially on a collection, not really a list. So you can use the iterator on a collection without you looking at the list iterator. When you start working on a list, then we can go next and we can get the index of the list, and we can start working at the order and like pick up the top of the list, the bottom of the list, the previous item, the next item, all of the different order that's associated with it. So it builds on the same interface, has the same methods, but the methods are implemented slightly differently because it's giving us a list behavior. So here we have a has next, where we also have has previous, and we have next, and we also have previous. So we can go, if we have an order, we can go next and previous to it. Next index and previous index also works the same way. So when it's all at the end of the list, next index will return list.size. So when it's at the beginning of the list, the iterator is at the beginning of the list, it has a list previous index will be -1 because there's nothing there. It actually comes back as nope, there's no previous item if you're at the beginning of the list. Removes the element last returned by next or previous. So you go to the next, you remove it, then you go to the next, you remove it, go to the next. Add inserts the object into the list of the front of the elements. Would set the last element returned by next or previous with any particular object that you gave it. Replaces the object and sets it with a new object, essentially. Potential problems with list iterators and list iterators. Let's see how far I want to go with this. Now, at this point, I want to stop and show you the programming, because until I start talking, it's ridiculous to start talking about problems when you don't know how essentially it looks. So let's start doing assignment number 3. So that's what you're all waiting for. All right, so I took the liberty of loading it into my clips already. Let me show you where you can get this file that I'm looking at, and hopefully it's where I think I remember putting it. So if you go into the Object-Oriented Programming in Java course on bhacker.com and you go into Course Materials, which is the first link, I put this new link right here. It says example assignment number 3 examples. And I put out a little cheat sheet so I can remember which. There's like a dozen files in here, so I can't remember which one's which. But this is, if you click on this, you'll be able to download. It's called jp-assignment3.zip. In there, you're going to get a ton of stuff. I didn't do the assignment for you. If you remember the theme of this assignment, you have to create a stack and you have to create a queue. And it's, what is it, stock or something? Yeah. So you're probably going to want to have an object. You're probably going to want to make an object called stock or something and put it inside of a stack or a queue and then organize it somehow. You know, I don't know, use it to do some calculations and stuff. I'm not going to do the calculations, and I'm not going to follow the same theme, because then that would be way too easy for you. But instead, if you unzip this file here, and where'd it go, actually? Well, it used to be on my desktop. If you unzip it, let me make this bigger so you can see what I'm talking about. And you import it. We should know how to import it into, it's an Eclipse project. You should be able to import. You guys know how to import? And no one's answering. Are you guys awake? You're still listening. Can you hear me? Can you hear me now? Let me show you how to import something just in case you don't know how to import. Actually, let me just do this here. I'll just import this again. Actually, hold on one second. I'm going to pretend like I don't have this in Eclipse so you can kind of see what you're doing here, because if you can't do this, you're going to be lost completely. Object-Oriented Programming in Java, Course Materials, Assignment number 3 examples. I didn't see it on my desktop, so I'm going to save it. Okay, I guess it was on the desktop. I am going to go to the desktop. Where is it? Here it is, way down here. Unless it's somewhere else. Oh, here it is. I got 2 copies of it. Here, let me get rid of this one. I got a mess going on here today. I unzipped it, and here it is right here. And I'm going to remove it. I'm going to take it out of Eclipse real quick here. So, let's see. Delete. Let's just see. We'll see how accurate how accurate the file is. Delete it. I deleted it off the disk. It's gone completely. This is what you're going to do to bring it into Eclipse so you can practice this stuff. Take a look at it. And so you're going to go File, Import. I think I showed this for the Android class. I don't know if I did it for this class. That's just why I'm doing it. When you go into File, you get some general options. Archive File, Existing Projects into Workspace. That's the one you want. Click on Next. And then you're not going to see anything. It says Import Projects. You can click the Browse button. And I put it on my desktop, so I'm going to click on the desktop. And here's that folder. All you have to do is click on the folder. So just click on, and anything in the folder that's an Eclipse project is going to show up in the window. So I'm going to go Open. And if it shows up in the window like that, it knows it's an Eclipse project. This is the Eclipse project. It's called JP-assignment number 3. It's on desktop. So I'm just going to press Finish. And in doing so, over here on the left-hand side, now I have it back. It says JP.assignment number 3. So I got it in there somehow. So now it's in there. That's how you're going to load this example up. All these examples are going to work. So the way you're going to run this example, however, because this is a project that has a bunch of garbage I just stuffed in it, it makes it easier to kind of look at. You're going to run each one of the files individually. It doesn't really run as a project. Some of the files do work together, however, but I'd leave it all intact until you figure out what's in there before you start deleting stuff out of it. But you're going to get everything whether you like it or not. If you wanted to, you could import just one of the files, but it's a little bit more, you have some more steps, more steps to look at. So I'm going to click on the first one here. It's called List Example. And it's a little deceiving because List Example has a couple things in there from the last lecture that I kind of hacked at right before the class started. And I kind of just put some stuff in here. What I want to do is, before I go through this first example, I want to review the concept of abstract classes and interfaces with you, and inheritance. So we'll see the big picture, because you'll need to do this Maybe you don't need to use interfaces, but you'll need to use, you probably won't need to use abstract classes either, or inheritance. You probably could just make a stock object and just load up the list with stock objects if you wanted to. But then you wouldn't be learning anything, so let me show you this interface here. So remember we had a theme going on last time. It was a person that turned into a student. So I created this person class for you, and it's in this file. You have all this stuff. It's in your file if you upload it, if you import it. So last time, or the time before, we talked about abstract classes. Here's your first abstract class. So it's called abstract class person. And I put some data in here. I put a string name and a ID. I don't know, you can put anything you want in there. I put a little default constructor in here, set the name to no name, and the ID to 0, and I print out I'm a person. However, it's not going to ever print anything out if I make an instance of that person object, because I can't make an instance of person because of that word abstract. I could never make an instance of this object. However, it's abstract because down here on the bottom I have this abstract class. And the abstract class I have is public abstract string toString that I decided to put in here. I can have other abstract classes, and let's put one in here. I'm going to put another abstract class in here so you can kind of see what this does when you start looking at this. So I'm going to make up one, and I'll just put it here. Actually, here, I'll put it down here next to this one down here. I'm going to go, and it has to be public, because I have to get this class outside. I don't have to use the word public probably. I can probably use anything I want actually. I can in fact leave it public out because by default it is public if you remember. I'm going to call this an abstract person. How about age? We all age, don't we? So, or grow. We'll just call it grow. So now I have a new public, excuse me, I have a new, oh, I didn't give it a data type. How about void? Void grow. No. Okay, what's it telling me? It's telling me remove abstract modifier, remove method body. Oh, that's the problem. Yes. All right, so waking up today. Abstract classes don't have method bodies. So I tried to put a method body in there. Yeah, you can't put a method body in there, as that message just told me. I'm sorry? It's a method. However, if I put a method body in here and leave it blank like I was trying to do before, in fact, sometimes it's really good when I make mistakes typing because it kind of reiterates points. You see I have this like little red thing over here. And it says, well, what's wrong with it? Well, you got two choices. If you put you can remove the abstract modifier, so it's no longer abstract. But I want to create an abstract class. Or you can remove the method body. Because it's contradiction in terms. It's either abstract or it has a method body, but it doesn't have both. So it's asking me to do one or the other. So I'm going to say remove method body. And it puts a semicolon at the end, creates sort of like what's called a function prototype. It's a method prototype. So it tells me that grow is existing as a method, and it's abstract. So is this one down here. And you notice over here, I put this one in here to show you something actually from object. Object has a toString method in there. And when I'm doing this, I'm overwriting the Java language object toString. So when I did this, I created an abstract, which means, all right, let me go back to the concept of abstraction. This means every class that is built from this must implement toString. And it must also now implement grow. So you're going to see a little error message that comes out because I added this as soon as I saved this sucker here. And save it. Now I'm going to see some red stuff appear over here. Because I built some classes from this class. And I didn't implement grow. Grow never existed until a few minutes ago. So I'm going to go down here. The closest one here, you can probably see this here. So person is a person. Before I get to person, let me talk about student. So I'm building a hierarchy here. Same thing as we had in the lecture, person, students. But instead of making student an abstract class or making it inherited from person, I'm making him an interface. So here we have the interface of student. And the word interface is what's separating it here. It's not a class. I can't make an instance, just the same way as I can't make an instance of that abstract class person. I'm going to get an error if I try to make an instance of student. It's It's not a class, actually. But student in here has a string, who am I, that identifies it as a student. So if I ran who am I from any object that was inherited from, that included that interface, it's all, this is an example of tagging. So it's all going to come back and say, you're a student. In there, I put this tag in there, and it said all these objects I'm going to create now are student. If I run the if I look at this piece of data, and I made the data public, so I can get at it at the main driver program or anywhere I want. Actually, and we can see what happens in the main program. But I put again 3, and I didn't call them abstract. Instead, I just put in, and the interfaces have abstract methods, just like abstract classes. In fact, the interface looks like an abstract class. The only difference is we call it an interface instead of an abstract. So we can include that one along with another one if we wanted to. And so these are really abstract methods, and the abstract methods is for all students that we're going to create. Anyone who's a student has the ability to graduate, has the ability to register, and has the ability to change majors. Why are we doing this? Because every time we want to create a certain type of students, we want to make sure we implement this behavior, because we're setting rules, I guess. And we're saying, you know, hey, all students should be able to graduate, register, and change major. So this is all I put in the interface, actually. But let's use the interface. Let's create a class that uses the interface that inherits from person. And let's talk about, I'll talk about grad student first. So I'm going to click on grad student here. Grad student extends person, implements student. You can see I got this little error going on. If I put my mouse over this little thing, it's going to say, well, add the unimplemented method. Remember grow, I think it was, I put in there. So if I, or make type grad student abstract. If I don't want to implement this, I can make grad student abstract and then extend another class from grad student and then implement it. Continue the implementation. But in this particular case, I just want to use this one because I don't want to confuse you too much. So I'm going to add the unimplemented method. If I do that, I just clicked on that button. Down here on the bottom, now I have grow that showed up. If I do this initially, as an example here, and let's just take out all this. Oh, here, maybe if I cut and paste it, I can just put it back in without having to retype it. Let's see, edit, copy, and I'll just cut. There we go. If I cut it all out, and I left the constructor, because I want the constructor in here. Actually, I'm not going to get an error on the constructor ever, except for when I start running it. Now it's going to say add implemented methods. And I go, yes. Now I'll put them all in here. Where to get those from? It goes from the interface. Anything that's in the interface has to be implemented in any class that implements the interface. Because this word implements, it says we're going to implement students. And student has graduate, register, change major, grow, and toString. So I wonder if I can get all that implementation back. Let's just undo. And oops, undo, add unimplemented method. Undo typing. Ah, perfect. There we go. Now we're back. So, there we go. So what did I do here? I implemented the methods. Instead of putting something in there, I just put this, you know, system out, cheers. If the graduate student graduates, it says grad student graduated, register, grad student registered, grad student changed major. Obviously, you would have them do some functionality that would be associated with each one of those methods. But in this particular case, it's a grad student that extends person, which means I have a name. So this part's the same as what we've been doing so far. We still have a name, we still have an ID. Everything that's inside a person is now inside of this grad student. We inherited it. That's the inherited part. This part here is the implementation of student. We've tagged student with only I think something that said under major, perhaps, or something like that. But we didn't give it anything else. Instead, we decided we want to have these methods implemented. So if I save this one, the red thing will go away because I added the grow. A grow method that was missing. So now you see the red thing's gone away. I also have med student. Med student's the same. It extends person and implements students. But med student's going to be missing that method as well. So I'm going to add that unimplemented method. So now I have grow down here on the bottom as well. But I also am missing another method. No, I'm not missing another method. Do I have toString? I have toString right here as well. So I have everything I need now, so I'm going to save that one as well. So I can see that med students and grad students ready. Now I have undergraduate student. Undergraduate student again extends person, implements students, and I actually have to add that unimplemented method grow to this one too. So if I've left anything out, and here it is right here now, and this is just auto, I just left the auto-generated code here. It's not, you would actually fill it in. So if you ever see this, it means that, you know, when you implemented something and you added, you know, you included it in the class, but you didn't include the method body. You'll get this when you do on-click listeners, because when you implement an on-click listener, you're just going to want an on-click method. If the on-click method is not there, it's going to say, hey, you want to add the unimplemented method? If you ever see add unimplemented method, it means you're extending an interface. You're implementing an interface, but you haven't included something that's in the interface. So it's a way of kind of guiding you, I guess, through making the object complete. If you don't want to implement it, the other choice you have is to make this class abstract. If you make it abstract, then you have to eventually implement it if you're going to use it. But abstract basically means it's not implemented. So it's either going to be implemented or it's not going to be implemented. So I'm going to save this as well. And that's my student interface. So what I've got now in my hierarchy is a person, and I've got a student interface. And I can't make an instance of student, but I can make instances of grad student, which extends students. Extends person, implements student, and I have undergrad, and I have med student that I put in here too. Now, I made, and this is probably the part I probably should change. I made list example my kind of guinea pig driver program. So if you're looking for where this code is actually located, it's in list example. List examples chock full of stuff in here. The first part is what I kind of wanted to show you in terms of the inheritance and the interface. So the class list example in the main method, this is just a driver program, it doesn't really contain anything. Let's look at the interface to see what the interface gave us. So we're going to make some students, because usually when you call the interface, like for example collections is really the name of the interface, and there's a list interface and there's a queue interface. So we're really making students, because the interface that we're working with is called student. So if you want to label things kind of to make logical sense to other people who are looking at your code further down the road, if you have different types of stock, your interface is probably going to be called stock. What's stock going to have? It's going to have a name, a ticker symbol, maybe a value that's associated with it. So every stock that you create that's of type stock, of the interface type, is going to have a name, a ticker value, symbol associated with it. So it kind of makes logical. That's how the sense is supposed to actually work. So I've made some students, and I made a grad student, a med student, and an undergrad student. If I do this, if I take in, I put this in here to kind of show you, if I go person C, I have A, B, C, here, I'm just calling them. If I call C, I'm going to get a little message here that says rename, duplicate. Okay, let's get rid of this. Okay, that's the problem here. Let's see. Right now I'm going to get something that says you can't make an instance of this guy. Can't instantiate the type person. And why not? Well, because person's an abstract class. If I change this around and said student, well, the student's not going to work anyway. Student is actually, I'd have to go like that for student. There we go. Well, that one's going to have a typo here, but it's yeah, forget that. I'd have to actually, let me get rid of this comment here. Let's do that. This is going to tell me that, oh, typecast to C to student. Well, I could typecast person to students. So I can go, oh, okay, well, let's do that. And then I can get another error message. It says can't instantiate the type student. Why can't I do that? It's an interface. Student's not a class. So the compiler sort of knows, or Eclipse sort of kind of can navigate you to a certain point, but you sort of have to remember you can never make an instance of an abstract class. You can never make an instance of an interface. It's just not going to work. However, You could cast something to students. Everybody's a student. All these guys are students. So I could say student C is equal to student. I could go like this. I could say student C is equal to student. I'm going to cast now to a student, grad student. Whoops, if I spelled it correctly. Grad student. Grad student. Oh, I'm sorry. A is a grad student. Hello. A. And then now I've taken this grad student, I've turned him into a student. That's going to work. And so what can I do with student? I can't really do anything. I can go like this. I can go system out, if I spelt it correctly. This is why I typed this ahead of time. Dot print line. Oh, let's go A dot. What was it? What's inside of A? It was, who am I? Who am I? There we go. There we go. Alright, so I can say, yeah, A dot who am I? And I can say, what is this? Well, this is a static using, well, yeah, I know. Remove static modifier on who am I. Yeah, let's just do that. We remove the static modifier so I can work with it outside of the class, essentially. Actually, I probably should put that back. But anyway, because I'm not using who am I anywhere, it doesn't really matter. I'll just leave it there. But I can get at this and I can go, well, okay, so we know we're a student. So if I forget, let's say, this is really actually doesn't make any sense because I should really put it inside a grad student. Because eventually this A that used to be a C, or excuse me, this C that used to be an A, they got cast to a student because it is a type. Although I can't make an instance of a student, I can use it as a type. And this is a type reference that I created. Eventually I'm going to probably want to turn it back into something. I'm going to go, well, what are you? So the tagging works nicely to know that who am I. If I reset who am I again to grad student in a grad student and this and that, then I would know who I was. And I could use that, or I can do it as instance of. So I can check, is this object an instance of person? Is this object an instance of grad student? So there's a couple of different methods that you can do that. This is what they're calling tagging. You can tag usually with the interface. Like I can set who am I, and it's going to say, you know, a lot of people use interfaces for tagging purposes. You don't really have to unless you're going to be converting objects back and forth all over the place. So let's just I want C in here for this example, so I'm going to take this guy out and this guy out. And let's see. You know what? I'm going to do typing here. Hold on a second. I just want to check real quick on something. No, it was in here, wasn't it? Actually, all I got to do is not save it. Oh, it didn't save it. All right, well, just I'll just do it this way. There we go. Alright, so in this particular example, to continue on with it, I've got 3 instances of objects that I created, and the 3 instances I can actually take the instance, because they all include who am I can actually run and that system out on any one of these instances. I can cast it to another instance, but I've got a grad student, and a med school student, and an undergraduate student. And the Larry, Curly, and Mo, and they all have IDs set 100, 101, 102. And here I can say, you know, A.graduate, B.graduate, and I can go, you know, C.graduate. And I know that because they're all students, that every one of these methods is going to work. I can also register them, and I can also, I don't know what the other one was. Huh? Change major. They can also change majors. But it's kind of like the two-string method that can be used on any single object. You know, the method exists. So one of the other reasons why you use an interface on it is because then you make all of the methods consistent. So I can graduate, anyone can graduate, any one of these types of different objects can graduate. They can all register, they can all change majors. What is this? Oh, not a student. Well, okay, whatever, that was left over from the other example. So now they can all graduate. And so here's the interesting part now. So let's say I want to take this object. This is, for example, could be the implementation of your stock for this particular program. So I'd make a you know, instead of a person, make a stock. You don't have to use an interface. You don't have to use inheritance. You can just create a regular old object, call it stock if you wanted to. can have different types of stocks if you wanted to, but you don't have to. Import java.util up here on the top. This is the import, this is the new package that we're looking at for the collections. And then down here I'm going to make a list. And this is a list that stores person objects. And I know that because I've set this right here, this type right here. And this is the new part for today. It's not a cast. If it were a cast, it'd have opening and close. It would look like this if it were a cast. This is an upcast or a cast, you know, when we change one data type to another. The opening and closing, those little arrows that go back and forth like that, that's a selection. So I've selected this list to hold persons. Anytime you're referring to the list, in this particular case, if you leave this out, for example, you've made it ambiguous. You can leave it out, but you're going to get this little error message. Oh, actually, well, now we're going to get a message down here. But we could do this. We could go object in here. If we did that, we made it, and if I spell it correctly, with a capital O, we've made it generic, but we don't have this method. We don't know that this method actually exists on this object, so we have to cast this object to a graduate student or to a student in order to run the method. But because we're going to hold, what was it originally? Person? Person. Was it hold people? Yeah, good. I was like wondering what I put in there. These are all people. They're all instances of people objects. So they can all be kept in the same array as people because they're all together, even though one of them is a grad student, one of them is a med student, one is an undergraduate student. They're all people. So this list here, so if I created a stock and I created a new instance, inherited an object called Facebook stock, one called eBay stock, and they're all different types of stocks, maybe because they had different specializations or something associated with them. They're still all stock. So they can still all be kept in the same cast in terms of what they are. If I do that, I'm not going to have a problem down here because I still have to cast this to a person because this functionality get name is from person and it's not from an interface. If I wasn't using this, if these two here were like this program will work just fine because my array, my list, is holding instances that are all compatible with student too. But I want to be able to run methods that are people methods. So I'm going wider up the hierarchy, and I'm going to say person now instead. If I narrow it down too far, I can't include the functionality that I need. The functionality that I'm looking for here is to get the name of each one of these guys. So in my implementation, this is the new part from today. You're wondering, well, where did lists come from? You can put a space here, or you can not put a space. I like to put a space because then I know that it's the list type. And then the name of the list is my list. And it's going to be a new array list. This is the new part for today. ArrayList, which came out of the first or second slide that I gave you, is a subclass that exists. It's an object type that exists out of collections. Collections exists in Java utils. So I don't have to, if I didn't put Java utils up here, I could go collections. In fact, what would happen? Over here. If I put this on here, it would say import ArrayList. If I did that, or import arrays, or import cast, clear the cast to array. If I did this, I would come up here. Now I've got Java util ArrayList up here instead of Java util, because it's really part of ArrayList, but list is actually part of a different section of that same package, so it's better if I go like this. It's better if I put the asterisk in there, then I know, well, it's everything past that. So I'm going to get list as well as ArrayList. Okay, so let me go back down to the list. So this is a list that stores person objects, as we can kind of see here, and it's an ArrayList type, and it's in a list object. Okay, so we have, and you're wondering, well, where did this stuff come from? Remember those boring PowerPoints I gave you in the beginning of the class to show you add, remove, next, has next. Built-in methods that come with ArrayList. So I can say, if I wanted to clear it, there's nothing in the list, but I'm just putting this up here to show you can clear the list, which makes it fresh, brand new list. And then I'm going to go add. Well, add's got a couple of different syntaxes to it. For example, here, if I go my list.add, I can see I can have, well, I can put a person element in there, I could put a collection in there, extending person, I can put an index value in there. I can make it like that, you know, where I'm adding, you know, a person E in here, which is kind of like what I did here. So I put C in here. I can actually specify the index order, so I can say add to 0, add to 1, add to 2, add to 3, the index values. And so now I'm saying that the array list starts with 0, 1, 2, 3. Some of the structures are implemented. In fact, the list, I believe, by default is implemented starting with 1, which is kind of weird because up to this point with arrays, you've been taught, and I'll show you arrays before today's over with, you've been taught everything starts with 0, index values are 0. Well, it doesn't have to be. What if you create your own structure? And if you're going to do this method, you can start it with anything you want, really. You don't have to start with 0. So you have more flexibility if you do this. Plus, I didn't have to create this array. And in fact, I can add items. Further down the road, I can add another item to it. I don't have to specify how big this is when I do a regular old array or something like that. So I'm going to say new array list. I'm going to have some other examples that are just going to say new list that aren't array lists. You know, so they'll look like that, you know, and so this is going to give me a problem, but so I'll just go like that. But I have some more ways of doing it. So I put 3 items. I put Larry, Curly, and Mo are now in the array, and now I'm going to system out item number 1, and I'm going to use this kind of like an array, but except for looking at the index value, now I'm using get. So we can set, get, add, clear, delete, remove, rename. You can, all these built-in methods are what you have to run on the object. Classic error is to try to do this and go my list, and then think, oh, this is an array, you know, 3 dot something or other. If you're familiar with arrays, if you're not familiar with arrays, you don't have to worry about this at all. But and then you go, well, what happens with this? And you look at this and go, well, it's not an array type. You can't resolve. It's a list. And list has methods associated with it that are run on the object. So we're not looking at index values in an array, it's an array list. So it's an object now instead of a built-in data type. So now we can do a .get, get 0, get 2. And we use it the same way though. We can say, okay, so now we've gotten 0, and 0 is A up here. So this is really A.getName, if you think about it. So the name of A, which is Larry, is going to print to the screen, and this is going to be Curly's left out. I just put item number 3 in here. I put Mo is going to print out or something. So we can actually, here, we'll see this part print out so you can kind of see what it looks like. And to run this example, you're not going to run the package. You're just going to click on the file itself, right mouse click, and go down to Run As Java Application. If you're running these examples. If you run it from the package, it's going to go, which main do you want? And we can see, oh, I had some stuff at the top. Here's the 2 lines of code I was just showing you. We have item number 1, Larry, and item number 3, Mo, that printed out of that array list. Up here on the top, we ran the graduate student, the med student, and the undergraduate student graduated because I ran these methods here. And in those method bodies, I implemented a system out for them to graduate. So let me continue with this example. That's why I said this example is kind of weird because I got like 5 or 6 different topics all in the same example. But I was too lazy to move it out. I just started adding it to it. But all right, so let's make a generic object instead. So this array was a person here. So this is an interesting concept. We say, well, object is equal to new object. Isn't everybody an object? So we're not creating a person, we're taking an object, but can we take object and turn him into a person? But if we have person, we can turn person into an object. So it's just kind of weird. No data type is being specified for multiples here that are being used. I'm not, I decided not to use object, but I did actually use object. I put them in here. So this list here has got some warnings on the side, and the warnings are going to tell me that there's no data type. Instead, it's using what's called a raw type. A raw type is object type because everything is an object. So even this list the type of item that this list is storing is a raw object, which is just object. So if you click over here and you go over here and you say, oh, look at that. There's a way of suppressing it actually. Here it is, add suppression to the list. There we go. You can put raw types here. It's just basically what you're doing is you're getting rid, for people who don't like to see yellow, you're getting rid of this. But it's okay. That's the only way you can fix the problem, really. And it's not really a problem, it's a warning. It's letting you know that it's raw. You didn't specify the type. So list is equal to new array list, no type. So what I got in the list? I got numbers, letters, and I got this weird old object that I created up here that's nothing really. So an object here is got put in here. And you're like, well, what does that mean? Well, all objects have toString associated with it, as I mentioned before. So I can run toString on the object. I can't really do very much to the object. I can compare one object to another object, stuff like that. And now it said list.add1, that's a string. 2, integer, float. Actually, that's really a double, but it's kind of, it could be a float. Character. Put a bunch of stuff in there. Okay. Now I'm going to system out my list plus the list. You know, how can you do that? There's no iterator here. Well, what is that going to do? Well, actually, that's going to do this, actually. My list, here's that line of code right here. That first object reference in here is this is the object, this is the toString, well, it's the reference to the object. So out there in the runtime environment memory, this is the location. This is like the pointer, actually, up to the object address space. Because there's nothing, it's just a plain old object. And if I did that with a person, it would probably print out the same thing actually as well, because there's nothing, unless I implement the toString. So, in fact, I did implement the toString, didn't I? Did I do that? Let me show you something actually. We implemented toString. This is an object, a plain old object, that has a toString method, regardless of what it is. I overwrote the toString over here in, let's do a grad student. Let's do it because I put some stuff in grad student here. So the toString is going to print out, instead of printing out the object reference, and maybe I should show you one way and then show it to you the other way. You know, we'll do this way here first. This way here, I'll comment it out first, so you can see what's going to happen before I overload this method. And this is an example of overloading actually as well, so I'm covering a lot today. So let's see, we need to make new grad students, or actually we have a grad student up here. I made one up here. Grad student is A, and he's Larry 100. So I could use A down here. I can just put in here A dot toString, and if I run this thing, it's going to print out A's address space now instead of object, which was kind of basic. Oops, can't do it that way. I have to do it this way. List example. And stop me if this doesn't make any sense. I just kind of went off on a little tangent here. Null. Probably because he doesn't have anything set for it. It's just nothing. I implemented it, but there's nothing there actually. It's not going to do anything. It's null. So theoretically, now because I've implemented the I have to implement the toString. If I implement the toString, it should do something. So let's see if this test works actually. So now if I run toString, am I implementing grad student correctly? Yes, I am. This is grad students. Now there's a method called toString in there that's going to run not from an object, but it's overridden actually. And it's overridden in grad students. So now when I run it, oops, if I run the right one, hopefully this works. If not, it has something to do with my array. It does. What's wrong with my array? I probably have to cast them. Well, theoretically, there's something wrong with my syntax, but theoretically, once you implement it, the new behavior should show up, not the old behavior on the object. And it's probably because this is not an A. I've put the object in an array of nothing. I have no type associated with it. So either that or A is not a grad student, but I think A is a grad student. He is a grad student. No. I will leave that one alone. But essentially, once you overwrite it, it should run the new behavior that's associated with it. If this were actually an array of grad students, it would probably treat it like a grad student instead of an object, which it's treating it like a generic object actually right now. But I also see that I have 1, 2, and I have all this other stuff in here as well. So the items themselves are being printed out with my list. And what I'm showing you actually in this particular example is that I basically have said system out my list plus list. So by using the name of the list, I'm getting automatically, and this is built-in functionality for the array list actually. I'm printing out the starting address of where all these items are located essentially, just like a regular old array if you think about it. So what do I've got up here then? Now I'm going to print out 2, print out 0. So I'm doing the same thing as before. I'm getting item number 2, getting item number 0. On the bottom here's 2, which is 2. 0 is null. What happens if I do this actually? Let's see. I'm kind of curious. There's something fundamentally odd with the logic actually. I probably should have tested it ahead of time. No, I'm still getting null. I'll fix that one for next time. But I'm sure it has something to do with the type of it being a generic object and not being a graduate object. But we'll see. I could cast it. But anyway, long story short, further down the road, to continue the example, I'm now using what's called a linked list. So this up here was a regular old list that I was creating and playing with. And I've now kind of said, well, let's make a different type of list. So this one here is called an array list. Excuse me, it's called a linked list. And a linked list is now extending from linked list. So I guess I could have called this one array list, but it's still, I'm not using any of the array list concepts. I'm just using the list methods that were associated with it. So what have I done here? I've said queue. I've called it in a queue, but it really isn't a queue structure. I just named it that. And I've said, well, let's give this stuff some types, so now we can play around with the types, and actually kind of treat it like we're supposed to. Because technically, you're not supposed to do that. You're not supposed to have a generic object, unless you're going to put a bunch of mix and match stuff in there for the purposes of just storing it. But you're never going to run any methods on this stuff because you don't know what it is unless you convert it to what it's supposed to be. But anyway, what I've got here is a linked list, and we're going to call it a queue. And so now I put some add first, add first, add first. So I'm sort of treating it like a queue. Is it a queue? It is a queue. I called it a queue. It's really a linked list. What's a queue? It's a list. We can add first, add last. And when we have the differences between a stack and a queue, essentially. A queue is going to be at the first. Actually, add first. Is that a queue? That's a stack. No, a queue is add the back, add last. Yeah, add first, add second. Yeah, add first, add first, add first. Okay, so 6, 7, 8, 9, and 10. So now if I print out the queue, I believe it's in here. I got my queue is 10, 9, 8, 7, 6. Because the first one was 6, 7, 8, 9, 10. So it is a queue then, because we put in 6, then after that we put in 7, after that we put in 8. So if these guys were standing in line at the bank, they would be in the right order. If you were reading this from right to left, going 6, depends. Okay, so your implementation, long story short, is depending upon your logic in terms of how you're adding the items into the list. The particular functionality says that there's a method in linked list. This is you can add to the front, you can add to the back. Actually, this is add first, add last is the other option you have. We can remove the last item. So now in our queue, we're going to remove the last item. So if we remove the last 2 items, after the last 2 have been removed from queue, now the last 2 we have on the bottom of the screen, we have 10, 9, 8. Because we removed 10, 9, we removed the first 2 items from the last 2 items that were put in. So if we were standing in line at the bank and one teller window opened up, 6 would go, 7 would go. And we were left with 8, 9, and 10 after 2 people were removed from the line. So this truly is a queue. One way of doing it, I'm going to show you another way in a few minutes here. Questions on this one before I move forward? Okay, don't worry about that toString thing. It's because the array is an object type. I've been thinking about it while I've been talking. It's a bad example. I should pull it out. Let's take a look at my queue. My queue is in here because we're talking about queues. My queue is right here. Actually, this is too small for me. My queue. And keep in mind, all of these, except for the ones I just gave you with the student, the grad student, the undergrad student, these are all separate now. So this one here, my queue, you can just pull it out, run it on its own. You don't need any of the other files to make this work. Everything is actually in here, and this is kind of a bad example, sort of, because, well, not really a bad example. It's using a queue. It's got an iterator in here. So instead of taking a list, and what we did before in the last example was take a linked list, treated it like a queue, made a queue, right? We also have a queue. It's further down the hierarchy. So it's implemented with a linked list. So what do we got then? So we have queue as the data type, and we're going to call it QE. We can call it QUE. We can call it anything we want. That's the name of the structure. It's going to hold strings. And again, you can put a space in there if you want. I don't like to put the space in because then it doesn't look like string is associated with the queue type. I don't know. And it's going to be a linked list. So the type is really queue though, but it's a linked list. So, okay. So it's because we're looking at an interface. We actually take queue and implement it if we wanted to, but we don't want to implement it. Unless you want to implement it, you can implement it. So some of these are interfaces that are being implemented. So this queue is actually going to be implemented as a linked list for this example. And what we're looking at is pretty much the same thing as we saw before in the previous example. We're running methods off of linked list. It's another form of a linked list. But we're using queue as the data type, which is the interface to it. So we have queue add. So I'm going to put it in like a stack of tape. It's like a stack of plates. If you put add B down, A, C, E, D, it's going to be added. And we're not really specifying the order. And then we have an iterator for the first time that we're looking at here. And the iterator is going to be iterating through strings. And we're going to run the queue iterator, same as in the lecture notes actually, where the iterator IT, you can call it anything you want, it's going to be equal to this queue here dot iterator, because queue's got an iterator method in there. And the iterator method is what's going to be used to traverse through, and all it does is gives us the has next functionality. So you don't have to create a loop for this. In the old days, what you did with arrays, when you created arrays, if you did this, you put a bunch of stuff in an array and you used the for loop, and you figured out how big the array was, and you did for the beginning of the array to the end of the array, check all the index values. So instead you're using an object reference, and you're using a method called iterator that's built into the object from its interface. All of them have iterators because they're all using the same interface. And so now we're saying the initial size of the queue, we're going to run the size method, given for you automatically. So, imagine this, there's no functionality here. Your third program is going to look really small. It's going to do a lot of stuff, but it's going to look really small because you don't have, no guarantees, but there's not that much you really have to do to it. You can create a person, stick them in. This is strings. This could very well be holding a stock instead of a string. And you're more than welcome to use this code, by the way. That's why I gave it to you. So here's another queue that you can create. I'm going to show you a stack in a few minutes as well. So we can print out the queue size by, and this is, I didn't put a space in here, but what we're doing is we're concatenating to a string queue size. And here's our big complex while loop. We got while IT, the iterator, which is the iterator object, which is on the iterator, on the string queue, running that method there. On this object has next. Then this one here is going to be equal to cast this next to a string. So take whatever iterator has, cast them to a string value, and then add them to the string value of the iterator value. Because the interface works on a generic object, we have to cast it. Because this could be a string object, this could be a person object. it's not associated with a type. It's a generic object type. So you always, when you use the iterator, you're going to have to like say, well, turn it into a string. If this was a person, turn it into a person or a grad student or whatever it is we're working with. And then we're going to print it out, q next value, and again, I'm going to put some spaces in here so it looks good. This is the value string that's coming out. So this while loop comes in and prints out all the values of the queue. Get the value that does not remove element from a queue. Here is a peek method. Peek goes in and looks, but it doesn't remove anything. Just looks at it, peeks at it. Here, get the first value and remove that object from the queue. Well, then that was going to be this method here, queue.poll. And how do you find out about these methods? You go out and you look at the documentation for all of the collection classes. And it shows you every single one of these methods. And you just run the methods on the instances of the objects that you're creating of these types. And here's the final size. It's going to print out the size again. So we're going to look at it, and then we're going to remove one item from it. And let's see what the output actually looks like. So if I run it, probably going to ask me to save it first. Nope. Here it is. So the initial size is 5, and we added B. Let's see how I added this stuff there. I'm going to go back up to remind myself. We added B, A, C, E, D. We peeked at B. We pulled B, and then now we have 4 left. And B is the guy on the top. So peeked B. So we actually kind of, is this Q? We put B in first. This is actually more like a stack, isn't it? Alright, so you gotta fix the logic if you're going to use this example. It's not really a queue. It's not really a queue, it's a stack, actually. I have a stack. I wonder if my stack is labeled as a stack or a queue. Anyway, questions on that one before I continue? No? We created a queue. It's interesting, though. I created a queue structure, but I used it like a stack. So you might want to add first to it instead of add, and then maybe, I don't know. It's a linked list, actually, not an array list. So use the methods to get the proper behavior. Lesson learned: you can create a queue and use it like a stack. You can create a stack, use it like a queue. Depends on what you're doing with it. It depends on what methods you're calling, how you're organizing the information as to what's going to happen with it. So let's see. That was a stack. So this is what the stack is doing. So each one of these examples is slightly different, however, all kind of bringing up different points. In the stack, I decided I'm going to show you a real array instead. So for those people who have never seen arrays before, here's your lesson on arrays. This is probably the only time you're ever going to see an array. If you're going to use this ArrayList, you'll never have to use an array for anything, if you think about it. But there's times when you want to use an array. So we created a variable called a maximum size just so we can set it. So we can change maximum size any way we want. The class is called myStack, and I put the main inside of here. So main makes an instance of myStack in here. And myStack, on the instance creation, myStack, the stack, is equal to myStack 10. Make a new stack of 10. Because the constructor takes the integer value 10, and it says, well, maximum size is equal to 10. Okay, and then create stack array is going to be equal to a new long max size. So we're taking a stack array here, and it's a long. It could be short, and it could be just integer. You don't have to make it long. This just allows you to make a really big array if you wanted to. This is the instance that's created. Once we create this, it's stuck. If we go past 10, we get an error message. This is static. It's not dynamically created because we're using this old-fashioned array concept. Top is going to be equal to -1, so we automatically say that this is what the top is. And so we have methods on a stack are usually associated with pushing and popping. We push an item on when we insert it, add it on. We take an item off by popping it. So we pop an item off is to remove an item. Push is to put something on, add it to the stack. So here we're going to push long J. Oh, we're going to work with longs on this entire stack. So we're going to say the stack plus plus. We're going to increment the stack, and that's going to be equal to J. So we're going to increment. We're going to pop it off. We're going to decrement minus minus. And this is like C++ actually, plus plus minus minus. peak, we're going to essentially say, well, what's at the top, which is the current value, actually, that we're looking at, because top is keeping track of the top of the stack item. And this, we are truly working as a stack, actually, if this works correctly. Is it full? Is the top equal to the maximum size minus 1? Is it which makes it 10? You know, because top, the items that we put in here was maximum size, and maximum size is set to S, and that maximum size is 10. So we're going to know it's full. So there's no check on here to see if it's full, actually. So we could put in 11 items or so. So we got 1, 2, 3, 4. Let's just do that. We're going to get a major error message. Actually, here, let me run it first, and then I'll do that. So you can see it work at least properly. Then I'll make it not work. But let me go through the code here first real quick. So I make an instance of my object, the stack, and I send it 10. Actually, I just changed that number to 1 and make it crash. And I'm pushing on 20, 40, 60, 80. And now I'm going to check, is it empty? Okay, if it's, while it's not empty, then pop the values off of it. And pop up here is going to remove, it's going to return the stack array, the top item, and this is the index value. That's the array 0 through 10, or 0 through 9, I should say, for this particular array. It's really a long number that's actually being put in there. And print out the value. The value is going to be equal to the pop, which is what that was at the top. And then print out a little space, and then at the end print out a little space. So if I run the program, my stack, it should actually work like a stack. And you can use this actually if you want to use this for your stack. And it's just printing out 80, 60, 40, 20. 80, 60, 40, 20. It's not a stack. It should print out, unless I'm reading this backwards, it should print out 20, 40, 60, 80. Alright, so this one's got logic errors too. It should be, is it a stack? Or what am I, oh, I pushed it in 21st, 42nd. Okay, got it. Yeah, now, okay, now I'm reading it right. So 20 was the first item, 40 was the second item, 60 was the third. Okay, yeah, you're correct. This is a stack. So, perfect. All right. Well, pop is just pulling out from our implementation up here is the top. Oh, excuse me. It's the incrementing down. So it's popping. It's taking the item off and then going down to the next item, which is the index. This is the index value of the array, actually. And the array is this long. This is a stack array that we created. Yes.
System has print value.
Mm-hmm.
The value should be the one which they popped off.
Yeah, it should be the one that's popped off. So we popped off. I'm reading this in the wrong order, but it popped off in. We put them in this way. See, if I were to visually draw this out on a board, 20 would be on the bottom. So 20 is the last one in and the last one out, which makes it last in, last out. First in, last out. First in is 20, last out is 20, because it goes this way. It's mine. It's what do they call that? Confusing because of the way this is printed this way and this is printed this way. So, but 20 was the last one in and it's the first one out. Excuse me. Yes. First one in and the last one out. Because it goes this way. 80.
So it should print, like it should print only 80, 60, and 40.
No. It should print all of them. Because the minus is happening after it. The minus is the decrement. So if you put it plus plus, it happens before you work with the value. Minus minus after you work with the value. If you go plus plus minus minus. So top minus minus, after you work with top, it's going to go top minus 1. Minus minus top, it's going to go top minus 1, then work with the value. Take that value. It's the logic of the plus pluses and the minus minuses. Whether you put them before, this happens before you work with that value, this happens after you work with that value. Which is interesting. Any other questions about this one? Oh, so yeah, what the other thing I was going to say is if I go here and I go 2, make this array size 2, but I add 4 items into it, I should get a runtime error of some sort. Let's just index out of bounds. And let's see what I got. I got index out of bounds. So, oops, I shouldn't have clicked on that. Cancel. And it says 2, yeah, because the index was 2 values, which is one of the old problems of doing it this way. Because whatever size you set the array initially is the size the array is going to be, and you can't change the size of the array, so the collections actually kind of avoid that issue 100%. Alright, so moving right along. So the iterator example here, and in here I've got a couple more stacks and a couple more queues if you don't like those, by the way, as well. In the iterator example, we're creating an array as well. So let's see, what have I got in here? Java util. This one's using an array list without a data type associated with it, which is why there's a bunch of messages here, because the example is kind of lazy. It doesn't put a data type on there. And so AL is the name of the array list, AL.add1, AL.add2, EF, put some numbers in there. And then here's an iterator. So you use the iterator to display the contents of AL. And so this is just printing out, here's our contents. And here's the interesting part, it's the same as we've seen before. We're running the iterator method from AL, which is the instance of the object of the array list. And we're using ITR as the name of the iterator that we're going to assign. And we're going has next, and then we're going ITR.next to get to the next one. And then we're just printing out the element at, and then we're printing essentially element here is the element here. And it's a strict object element, so we're not converting it to a string or anything, which is kind of dangerous if you think about it. This will print as a string, but it might be an object reference or something that may not necessarily print correctly, so this is kind of risky code. Not your best example in terms of best practices. Printing out a line, making another iterator, and modifying the items in the, using the iterator to modify items as you're going through the iterator. So the iterator is not necessarily removing items. It's not going to do anything unless you tell it to do something. In this particular case, we're telling it to append plus. So it's now element plus the symbol plus. That's going to end up in the list instead of just the regular symbol that was there. So we should see 1 plus 2 plus E plus B plus D plus show up. And then modifying it here by taking, we're going to print out the array again. What are we doing here? Modifying elements. Oh yeah, it's just going to print out the modified elements that showed up on the bottom. So if I run this example, what I should have is the beginning list and then the modified list. The original contents of the list, then the, oh yeah, actually, I was printing the list out backwards in here. So towards the end, you can see the code up here for it. It's essentially doing has previous instead of has next, and going from the end of the list back up to the start of the list. So it's basically showing you how to use the iterator to print out the items in forward and then also in backward order, depending upon which end of the list you start on. So by using has previous or using has next as the iterating method. And you can kind of see what the results of this particular scenario are. Alright, we have a set example. What you've seen a lot is the lists so far, which are ordered, and we can run set, we can run methods to process the items. In the set example, here's the set example. Real simple. And you don't have to do a set actually for the assignment, but you might want to know how to do it. The object reference type is set. It's a string. It's going to be a new hash set. New hash set comes from Java util. Same thing as queue, as stack, as all of the other ones that we've kind of set, or array list or array list. And so we're saying set add 1, 2, 3. So we're kind of treating this set like a list actually. It doesn't actually have to. It can actually have a key value. We can set a value for it. We can set a key for it. Or we can actually if we create a hash set, we could do that. Or we can also do just have a set of items that's not in any type of order at all, actually. So our set plus set, we're going to print out the set, and then we're going to sort the set. So we're using a sorted set here as a new tree sorts on the set. So the tree sort is going to be applied towards the set. And we're going to call this one sorted set, and then we're going to print out sorted set. So how's it going to sort it? Like a tree. But it's not going to look like anything you're probably going to be able to recognize. So if I run it, our original set 2, 1, 3, 5, 4, but I entered it in 1, 2, 3, 4, 5, which means there's no order to it. There's no first, second, third, fourth, fifth. It's just a set. So we don't have an index. And then our tree set, we have a 5, 4, 1, 3, 2. You know, it's organized as a tree structure. And if you're not familiar with data structures, don't worry about it. But it's just think of it as a sorted order. One's connected to the other. In fact, this looks like a binary, actually, kind of tree. But it gives you another example if you don't want to use a list. Let's see, we have linked list example. Another one in here. We've actually kind of seen some linked lists, but here's another one that's using a linked list with a linked list instead of an array list. So instead of looking at the array list, now we have the linked list. If you're familiar with linked list from C++, most people go, oh no, not linked list. It's a lot easier actually, because you're not really creating a linked list, you're using the one that's in the collections. And this example is nice because it's showing you collections, the comparator actually, which is another one we haven't actually talked about yet. So I'll get to that PowerPoint on Monday, next Monday. Actually, I'll talk about comparators, but because I know we're going to be running short on time soon. But the linked list example here is essentially creating my linked list, my LL, which is of type linked list, and it's going to hold integers. We've cast it to integers. And we've added -8 to 25, 48. And it's just actually going to be a list because it's a linked, it's a list structure. The comparator compares items actually, just like the iterator goes through, it iterates for next, next, previous. Comparator says, is this one equal to that one? Is this one less than that one? Is this one greater than that one? So it's comparing functionality. It's comparing integers. We're going to call it R. And on the collections, we're going to run the reverse order method to reverse the order of the list that we have got entered in. So we can run a sort on the collections as well. So this is just a hodgepodge of different methods showing you how you can actually manipulate this particular linked list by using the built-in methods. So the list sorted in reverse order will print out the list itself shuffled on the collection. So if you take and add the collection, use it as a collection, you can shuffle it because it's no longer a list. You can print it out, you can compare it, you can do all sorts of things to it. Here we're going to get the minimum and the maximum value from the collection. So if I print this out just to show you real quick what it looks like. We've got the list sorted in reverse order. I got the list shuffled around. We have the minimum and we have the maximum value of the list. Using a comparator essentially to say, is this item less than that item? Is this item less than that item? And then using a reverse and using a sort essentially to sort the list itself. So it's a matter of trying to figure out which method will perform the desired functionality. The last two examples, the stack example and the string reverse example, use the same stuff that we've looked at already, so I'm just going to quickly just tell you what they are. In the stack example, looks like I have a lot of stacks here, not too many, well, I have queues in here too. I guess I have an equal number of stacks and queues. I definitely have something in here for everyone to pick from. And as I mentioned before, you can feel free to reuse this code if you want. Here's a stack. This stack, like the queue, but it's a stack. We call it stack S, and it's a new stack, so we're going to use the stack. And we're using now the built-in methods that are coming from Java util stack. So it's yet another method of doing this. Instead of using an array list and creating your own, This is the easiest way of creating a stack, actually, because now we can use push and pop and everything's implemented for us already. Well, is it? In our particular example, you can see the code. It is actually, but it's basic functionality. We can modify it as well by extending on that class. If you want to inherit from it, you can inherit from any one of these classes and create your own implementation of this, actually. So, but I seriously doubt anyone's going to do that. So here we have the object S, which is of type stack. It's holding strings, and we have pushing 1, 2, and 3, and then we're going to print it out. We're going to peek. We're going to print out, look, which one's on the top? And then we're going to push 4 on there, and then we're going to pop 1 off, and then we're going to push 5 on there, and then we're going to get a count, and we're going to look for the searching for 2. Is 2 going to be on there? I don't know. Might actually pop 2 off or something. Who knows? And then while the count doesn't equal the count, and the count's larger than 1, while there's a count, pop it off till you get to the count, essentially. So it's just showing you how to do a loop, essentially, to pop something off. So, and count minus minus. And count's an artificial number counter that's being placed as you go through the loop to kind of keep track of all the items. Well, we're going to have a false up here because we've taken 2 off. So there's no search. Search on 2 comes up blank because we popped it off. But it shows you next up here, let's see, system outs. Let's see. Here's the next line here that prints out the peak that shows up here is 3, and we're going forward to. It's coming up false because we're popping off the value we're searching for. So. But it shows you the functionality. You can implement that any way you want, but you have the built-in. You don't have to create your own push and your own pop, essentially. It's built in for you as long as you're as long as you're creating an instance of a stack in terms of this right here, this line right here. String reverse through stack. It's just the same thing as before, except for this one's got an IO exception added to it. And this is kind of a peek at what we're going to be probably talking about in the next week sometime, probably not till next Wednesday, is that you can throw exceptions automatically, because when you start working with stacks and queues, you don't have to do this for your assignment, however, but you might end up with a case in which that it's empty, or it's full, or something's going to happen to it. So right here, this is the automatic exception handling that occurs, where it's going to throw an IO exception, because it can't read in anything else anymore. The string's going to be empty or something. So it's going to do something with that. But I'll discuss that in a lot more detail in the next week or so. But here's our stack, string reverse through stack, and we have 2 strings, an input and an output string. And there's our constructor to create the string as the input string. And then we have the do reverse method, and the do reverse method is getting the length, and then it's creating a stack, taking all the characters from the string, putting it into a stack. And then it's going through and finding out the length of the stack and pushing on each one of the characters for each one of the items that's in the string. And then we're creating an empty output, essentially. And then making sure that if the stack's not empty, we're going to pop everything off the stack to empty it out, which is how we're going to print it out, actually. So in here we have a string input is the Java source and support. String output is just a regular string that we're going to use for the output. And string reverse through stack, the reverser is equal to a new string reverser through stack input, calling the constructor, sending it the input, which is the string that we're going to print out in reverse order. Output is going to be equal to do reverse, and do reverse is that only method we have up here, and the method up here says, turn it around. Turn it around takes and make sure that the empty is empty, and then, that the destination string is emptied out, and pushes them on, pops them off one, and puts them onto the other stack. So we have one stack that's going to the other stack, essentially, in terms of the implementation. And then down here at the bottom we have a stack. And you're wondering, well, wait a minute, where did this stack come from? We didn't import it up here. We imported the IO exception. This is a really bad example, actually, because this should be in a separate file. And I put the little note in here that says this is a bad example. Because if I hadn't scrolled down, in fact I didn't remember until I scrolled down and I went, oh, there's my stack. I kept thinking my stack was going to be in a separate file where it should be. When you compile this, you will actually have a separate stack.class file. But this is not using the one that we looked at in the other example. It's implementing your own version of stack, and your own version of stack's right here. It's using an array. And this is the same stack code as we saw in the other example, where you didn't like the plus plus, the minus minus. But it's just doing a pop and a push, actually. This one is actually not doing very much outside of the regular basic stack functionality. But again, it's another implementation of a stack. If we run it, we send it a string. It should reverse it. Let's make sure it works. I haven't run these examples in a while. And lo and behold, Java something or other support. That's Java source and support. That is reversed. Alright, last but not least, we have a manually done linked stack. And I saved this for last because you're probably not going to use this example. It is called linked stack. Linked stack. I think it's linked stack. Where we have a a list. What do I got here? Again, we have another class that's declared inside of another class. We have two of them actually. We have, if you're familiar, and actually some people like this because they came from a C++ background and they're familiar with LinkedList. If you're familiar, you're going to love this one. We have nodes inside of a LinkedList. But it doesn't use pointers actually. Instead it's an object that gets stored inside of an object. So here on the bottom, if I start with the bottom item here, or actually I'll just start with the top. The linked stack is the stack structure, and inside of the stack structure we have a list variable. And there's our main program. Here's our linked list that we're going to use, where we're keeping track. So this is our own class and not the one that comes with the Java utils. We've implemented our own linked list class that's manipulating the linked list. That's looking at, so we have a list and we have a linked list, and it's the hardest way of doing it, so you're probably not going to do it, but you're implementing your own is empty, first insert, delete first, display the list, print it out, and then lo and behold we have the item. So if you're a C++ programmer, remember nodes. You created a node that carried a piece of data and a pointer to the next node. Kind of mimics the concept. We have the data and then we have next. And then next pointed to the next node, and then the next node pointed to the next node, and that's why they called it a linked list. And then we had, we put all that stuff, take all the nodes and we put it inside of a list. That's what this is doing. So this is nodes inside of a list, inside of a linked list. And then we're calling it from main. So I seriously doubt anyone in this class is going to take this approach. However, if you have time on your hands and you want to look at it, it's the same stuff we saw before, but it's all implemented together to mimic a linked list that's hand-coded, that's implemented on your own. So, and if you look at the main code, it's pretty simple actually. It's just creating, running a push and a pop, and displaying. There's a display stack method. So actually the functionality is more customized, and it creates a simpler main program. Actually, you don't have to do very much in main. You don't have to think too much. You just run the methods because the methods are implemented, customized for the implementation. So if I run this, and I'm going to get, hopefully, a working program that prints out the stack. Yep. Apparently we push, this is a real stack. Push some stuff on, we pop some stuff, we pushed more stuff on when we popped a couple items off. We created a stack, pushed 2 items on and popped 2 items off. So, and this one does work as a stack. But that'll be the mystery for you. Okay, so those are the examples, and believe it or not, that's all you need to complete assignment number 3. And assignment number 3 is to create a stack and a queue that works with a stock object, and it keeps track of prices. So when you put items on, when you create those objects, you create them of different prices. You know the order. You can actually put like a date if you want on them, or a time, or you can just use the index values. And then when you sell, you know what you paid for each item, what you bought for, and you can kind of tell profit and loss and stuff like that. And if you read through the assignment description, you'll get their exact details. I'm not quite sure what it means, but I'm not going to read through it right now. Okay, bye-bye. See you next time.